Hello there. So far we have seen the one-dimensional object and we found the centroid for those objects, right? So that's maybe bent in a circular form or maybe in the semicircular form, or that's going to be quadrant we have bent, and we found out the centroid. So the next topic is going to be here, the centroid for two-dimensional object. In this case, two-dimensional object means here the two dimensionals we are going to be considering and one dimension is going to be neglected. In that case, what it means, the two dimensions we need to be considered. When we are going to say the two-dimensional means it is representing the area, right? If suppose I am going to say one-dimensional means only the length of the object or any one dimension, either the length, width or breadth is going to be representing. In this case, two-dimensional is area is going to be coming. So now we need to find out the centroid for the two-dimensional object is nothing but the area. Suppose we are going to be taking. Suppose this book is going to be the some area is there. We need to find out the centroid. The centroid is nothing but here the area of the centroid means the total area is going to be concentrated only at the one point. Suppose, right? Then we can say that's going to be the centroid for the area. So similarly, you can take any kind of the two-dimensional objects. We need to find out the center for that area. So now I have taken, to make you to explanation or to more to understand, I have taken a one irregular object over here. So then this object is going to be how it is. So that it is going to be existed in the area. But in one-dimensional means one line will going to become. So this is the area is there. So then I need to find out the centroid where it is going to be. So that's maybe at this point, suppose I am going to be considering. So then for this part, first I am going to be taking here the x-axis as well as the y-axis. Suppose at a distance I have taken this x-axis and this is the y-axis I have taken. So now I am going to be assuming that is at a distance of xc with respect to the y-axis and yc with respect to the x-axis. So then how could you find out the xc and yc? So in this case also we are going to be assuming that the given two-dimensional object or the area has the uniform or homogeneous in nature. It means that the density is going to be constant here. At the same time, the area is going to be the area. Then what will happen? It has a three-dimensional object also. Then the thickness is going to be existed. When I am going to see from this one, the thickness of this object is going to be visible to you in this way. This is going to be your thickness. So in this case, from bottom to the top, there we can see. So the thickness is going to be maintained the uniform from this point to this point. So that's why the t also I am going to be considering the constant. That's why it will become the two-dimensional object. So now we need to find out. So what we can do? So in this case, once we are getting these values, so then I am going to be dividing the given area into number of elemental strips. So that already we have discussed. This is going to be your number of strips we are going to be making, right? So from this one, but after making this part, we are going to be, this part I am going to be saying, this is going to be del A1 I am going to be saying. This is the del A2, del A3 like that. You can take the number of areas over there. So then this is going to be the total area is going to be concentrated at point I am going to be assuming. So now you should find out the centroid for this. So in this case, what we have taken in the last classes, we have seen that. So that means the three-dimensional object, only one dimension is neglected because it has the uniform area is there. Uniform cross section we do have. So then in this case, what will happen? That body has certain mass we do have. So that mass we have already seen. The total mass of that one, mi. So that the total mass mi, that is going to be sigma I to 1 is going to be n. This is going to be your total mass of the system, right? As we know that the mass also we are going to be writing, that's going to be the rho into volume. Then again the volume I am going to be writing here. So in this case the volume I am going to be writing in terms of rho a L if I am going to be taking. In this case L we don't have, that is going to be your thickness of the member. So then in this case if I am going to be taking the elemental strip of this part, that's going to be dm1. Suppose del m1 if I am going to be taking. This is the total mass of this object. But we need to take the single elemental object. In this case, suppose this element I have taken, what is the mass? So that I am going to be taking rho and T is going to be the constant and only the area is changing. So I am going to be writing in this way. The rho T is going to be constant and dA is going to be varying. So that I am going to be taking, this is going to be your elemental. Similarly, del M2 is equal to rho T dA2 I have to take it. Similarly, the number of elements means the number of elemental mass we need to take it. That's we are going to be multiplying with the distance with reference to the reference axis, so that we will get it. So there we can see this is going to be the total area distance is going to be, here is the xc and this is the yc with respect to x. And similarly, this elemental 1 we do have. So then what will happen? This is going to be located at a distance of x1 and with respect to the y axis it is going to be the y1. So can you see, that's going to be with respect to x axis, this is the y1 and this is the x1. Similarly, a2 is going to be existed at a distance of x2 and this is the y2. Similarly, x3, y3 of the elemental 3. So this way we are going to be identifying the different positions. So how I can find out? By using the theorem of varignon. What is the formula we do have? A theorem of varignon means here the resultant, the momentum of a force about an axis is equal to the summation of the moments, the summation of the force moments about the same axis we need to take it. So in this case what will happen? This is going to be representing your total mass. That's the mass is going to be located with respect to the y axis, means that is what distance we will have, the xc distance we will have, that is equal to, that is the summation of all the elements with respect to the y-axis we need to take it. That's going to be here the sigma I is equal to 1 and del mi. And what is the distance it is there? x1 distance is there. Similarly, other elements also we do have. That's I am going to be taking the xi. Similarly, that I am going to be taking xc is equal to the sigma I is equal to 1 and del mi xi by what I am going to be taking, this m is equal to, we can take it this part, that's going to be sigma I is equal to 1 and del mi. So then what I am going to do, this m is equal to, we know that that's going to be rho T dA, we can take it. So that means in this case, so by using these equations we are going to be substituting in terms of the thickness as well as the in terms of the area. So what I am going to be finally to see from this equation, the sigma I is equal to 1 and del mi I can write it with respect to this point, rho T is the constant, dAi xi divided by sigma I is equal to 1 and rho T dAi. Right? Further simplification from this one, rho T will going to be cancelled here because they are going to be the constant. Then finally, so from this one, sigma I is equal to 1 and that's going to be xi dAi, I will get it, divided by the sigma I is equal to 1 and dAi. So that means this way we are going to be calculating the xc. In further simplification of this, the first moment of inertia, further simplification of this one that I am going to be getting, xc is equal to, that I am going to be taking the integral x dA by integral dA, I can take it. This way also I can represent the same in this technology. We need to substitute the values of your a values 0 to a. Suppose it is going to be distance existed in x direction is going to be 1 to 2 suppose, or y direction 1 to 2. That limits we need to substitute, but in this way I will get it. And similarly, how to calculate the with reference to the x-axis, what is the centroid that I am going to be taking here? That's the, so with reference to the y-axis, so that means with reference to the x-axis, what is the centroid it is located? That I am going to be taking integral y dA by integral dA and we get it. So this way, the first moment we can calculate by using the theorem of varignon.